Welcome back, students. So in the previous lecture, we discussed about the need for material testing as well as what are the reasons, factor of safety. We have discussed about the factor of safety. So now we will get into the actual testing process. The first type of testing is called as tensile testing. So tensile testing is done using a machine called as UTM machine, Ultimate Tensile Strength Measuring device. So what is tensile strength? Our first question is what is tensile strength? So this is what a UTM will look like. This may be the images of UTM. So this is the actual representation of a UTM. So what is tensile strength? So what's the opposite of tensile strength? Tensile means pull. You can remember this. Tensile means pull. Compression means pushing. In a spring, you can take the best example as a spring. When you stretch the spring, it is called as tensile load. When you compress the string, it is called as compressive load. Both are interdependent. So both these tests can be done using a same machine. Both tensile and compressive testing can be done using this UTM machine. So what is tensile strength? The ability of the material to withstand the pull. Compression is ability of the material to withstand the push. Both tension as well as compression resistance is required for materials which are subjected to elongation load, lateral load. You can call it as unidirectional load. So pull, push, both come under lateral load. So example of components which will be undergoing this type of loads, you can say the connecting rod in an engine. So that will be always subjected to pull and push. Similarly, your spring is a best example. A shock absorption system. A spring is a device which will undergo this type of loads. So your hydraulic systems, your pneumatic systems, the piston will undergo these loads. Piston is a best example. Connecting rod. These things will undergo this type of loads. So how you test this tensile strength? So actually I said about the UTM machine. So in UTM machine, there will be two parts. One will be your 1 minute. Take that pointer. This. So this will be your, these two things will be called as load cells. So they will be used to stretch the material. As you can see, this is the pull down action. So this will pull the machine, pull the component specimen down. So this is your actual specimen. The specimen will be pulled down until it fails. That's the purpose of this destructive testing process. How much load it is able to withstand, that can be calculated with the help of this extensionometer. So as you can see here, a device like this will be used, extensionometer. So the purpose of this extensionometer is to determine how much strain it is being able to withstand until it breaks ultimately. So here a concept can be related. In ductile material, first will be your elastic deformation, then plastic deformation, then ultimate tensile strength. After that, it starts to undergo necking. So the material will actually be elongated, and after necking, it will fracture. Whereas if you take a brittle material, there will be only elastic deformation, limited plastic deformation depending upon the brittleness of the material, and then there will be no necking. Fracture is the ultimate thing. So how the specimens are prepared? So there are two types of specimens can be used. One is a flat specimen and another one is a round specimen. As you can see here, The gauge length is similar for both these materials, but one will be of a rectangular cross section. Another one will be of a round cross section. So this will be your cylinder and this will be your flat piece. So both these things can be used. So if you see the test results, so this may be, I think, a copper material, alloy of copper, something like that. So what happens to the specimen? As you can see, it's copper, a ductile or a brittle material. So it's a ductile material. As you can see here, it is elongated and then it is fractured. But if you see the piece to your right, it actually broke into two pieces. There is no necking, as you can see here, there is no necking here, which would indicate that it is a brittle material. This may be wood. This is actually copper. So as you can see, the necking is clearly indicated in this specimen. First, it would be like this. This is your test specimen. After a certain point, necking will happen. Since it is a ductile material, for brittle material, there will be no necking. And ultimately, fracture happens. So this is regarding the tensile testing. So as you can see, this stress strain curve shows you the various curve for different materials. For low strength, high ductility material, as you can see, it is elongating more. High strength, high ductility, high toughness material, they are having appreciable properties. And similarly, low ductility, which means brittle materials, they only have elastic deformation and some plastic deformation, ultimately fracture. So this is regarding the tensile test. We'll see different testing in the upcoming lecture videos. Thank you, students.